Guys, welcome back to this week's discussion. So this week I would like to continue our discussion about 2015 OMK Bongsu by Gen A. Last week we discussed 3 questions, so this week we will have another 3 questions left to discuss. So without further ado, let's jump right into it. Okay, so for our soalan 4, we have a right isosceles triangle has a hypotenuse of length 10, hypotenuse being this one, the longest side, and 2 sides of length k each. So both sides have length k and are of equal length because they are the shorter ones, and the hypotenuse having value of 10 is the longest one. Wait. So by the Pythagorean theorem, so we have k squared plus k squared equals to 10 squared, which is our hypotenuse. So what does our question ask? What is the nearest integer to the value of k? So, okay, 2k squared equals to 100, as you can calculate for a little while. And then k squared would have value 50. But as you can see, if I were to have a cert in front of 50, the number wouldn't be very pretty. So how are we to solve this problem? So as you guys can see over here, 50 is stuck between 2 square numbers. We can use square number to check because square numbers, after they have been rooted, they still are integers. So we can write here as cert 49 is smaller, a bit smaller than cert 50, is a bit then cert 50 is a bit smaller than cert 64. Okay, give me a moment. So cert 64. So we know that cert 49 is 7, and then cert 64 is 8. So it's clear that cert 50 lies somewhere between 7 and 8. But to which number is it closer? So I would like to introduce the middle line over here. So 7 and 8. So the middle line will be 7.5. So when we square 7.5, it's around 56. To be exact, 56.25. So we can see that this 50 is smaller than 56.25, so it is closer to 7 than it is to 8. So the nearest integer to the value of k would be 7. So here we have problem solved. Voila. And then for the 5th question, so what do we have it here? This is a little bit more complicated. 25 girls and 20 boys in a class, and we want to divide them into 3 groups of equal size so that in each group the number of girls is 60% the number of boys. So what is the minimum number of students that we need to add into the class in order to make such grouping possible? Okay. So in each group the number of girls is 60% the number of boys, so the ratio would be 60% to 100%. So, okay, then the ratio would simplify down to 3 to 5. And then prior to that, you need to divide these into 3 groups. So the number of girls should divide 3 times 3 equals to 9 because, how should I say? Because you have already divided them into 3 groups. And then in 3 groups, you have to have 3 equal parts compared to 5 equal parts for boys. So, okay, let me draw this quite ugly pie chart out. So, the number of girls, as I write here, so it should be a multiple of 9. And then we want to have the minimum number of students to add. So, okay, so what we want to do first is we have to check what is the coming succeeding multiple of 9 after 25. So we can see that it's between 18 and 27. So 27 is the minimum number of girls we need for this configuration. So what this implies is that we need 2 more girls. So we jot it down over here, we need 2 more girls. Okay, So if we are to have 27 girls, how many boys do we need? So as we can use the ratio, so 27 times 5 over 3, because for every 3 girls you need 5 boys, so it will be 45. And then we already have 20 boys in this class, but we need the minimum number that we need is 45. So how many boys are we still lacking of? So 45 minus 20 equals to 25. So we also need 25 boys. Okay, so jot it down over here. And then what is the minimum number of students that we need to add into the class? Means girls plus boys, 2 plus 25, easy, 27. So we need for a minimum 27 students and additional 27 students, right? So here you go, problem solved. And then for the last question, okay, this one is a tricky one. A positive integer gives a remainder of 12 when divided by 2015 and a remainder of 21 when divided by 5,102. So what is the last digit of the number? So a point that I'd like to point out that is that many students, when they meet this kind of problems, their first instinct tells them that, oh, maybe I should find out what the number is so that I can do this problem. But the main point is, while tackling these kinds of problems, you actually don't need to find out what the exact number is, because look at the last sentence. What is the last digit of the number? So by thinking backwards, so we can try to figure out what kinds of last digits will appear, and then we find the coinciding one. So okay, we know that this number, maybe we just set it x, so it's a multiple of 2015 plus 12. So it's 2015 times a. I don't know what a is. So what do we want? We need the last digits. I'll just write the acronym over here. So what we want to find are last digits. So when we see, okay, when a equals 1, we can see our last digit is 7. Then when a equals 2, 2015 times 2 is a multiple of 10, then plus 12, so the last digit will be 2. And then, so these are the only two possible last digits for a multiple of 2015 plus 12. And then we look at the other one, remainder of 21 when divided by 5,102. 5102. Okay, we multiply it by a b. I also don't know what b is, but I don't know. Okay, so notice here that this is an even number and this is an odd number. So even plus odd is always odd. Then okay, but let's continue doing. Let's continue listing out our possible last digits. So when b equals to 1, we see that this sum equals to, the last digit is 3, and then 5, 7, 9, then 1. Then the list continues. Then the list repeats. It will be 3, 5, 7, 9, 1, like that, and so on and so forth. But we want to find the last digit of this number, so which means that it has to fulfill both standards, both terms. So what do we have here? We have our answer is 7. So we don't need to actually find out what the value of this number is, but we can zoom in at a smaller point, as like a smaller focal point, and then just deal with problems within that scope. So I hope that you guys have learned a thing or two from me, and so see you guys next week. Bye bye.